Hello everyone! For math today, we are going to be doing some multi-digit multiplication. Now, I know that sounds really complex and crazy and really hard, but it's not because we're going to break it down into smaller steps to make it way more manageable. So for starters, you're going to be solving this problem. Jonahs Garden is a rectangle with 16 rows for plants. He wants to plant two sections. One with 10 rows of carrots, and the other with 6 rows of beans. Partition the rectangle and label the sections carrots and beans to show how Jonah could plant his garden. So this is in your math journal, page 286. Please pause the video and solve this problem on page 286 now. All right, so for you to solve this problem, we know that there are 16 rows for plants in Jonahs Garden, and we could count, there would be 16 rows here. One of the sections, he wants 10 rows of carrots, okay? So carrots, 3, 4, 5, 6, 7, 8, 9. Okay, here are the 10 rows for carrots. All right, this is the carrot part. Carrot. Could have just drawn a carrot. Maybe I'll do that for beans. All right, and then he wants 6 rows of beans. 1, 2, 3, 4, 5, 6 beans. This is how Jonah could partition his garden to have 10 rows of carrots and 6 rows of beans. Now, you are partitioning or decomposing these numbers. In order to figure out how many plants he could plant, we not only need to figure out the rows, but also how many in each row. So let's go back to our carrots. Let's see, in each row, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, he can plant 9 carrots in each row. Now, how many rows of carrots does Jonah have? 10 rows. So to figure out how many in all, just like any array that we would do, 10 rows times 9 carrots per each row equals 10 times 9, what is it? 90. Excellent. Now when we go to our beans, we have to do the same thing. It's the same number in each row because this is the same amount as up here. But we can double check by counting if you don't believe me. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we know there are 6 rows of beans. The problem tells us 6 rows. Times 9 beans for each row. Ooh, 6 times 9, that's kind of a tricky one. You can do your fingers trick. 1, 2, 3, 4, 5, 6. 54. 6 times 9 is 54. So he can plant 90 carrots, 54 beans. If we wanted to figure out how many in all, we could do 90 plus 54. Oh boy, here we go. 0 plus 4 is 4. 9 plus 5, 9, 10, 11, 12, 13, 14. 14. So how many plants in all? 144 plants. So we really just did 16 times 9. The reason we did 16 times 9 is because there are 16 total rows, just like it says here. 16 rows. We know that there's 9 plants in each row. So now we know 16 times 9 is 144. It's way easier when we break it up into individual parts to solve this problem. So we're not going to be doing 16 times 9 and saying, okay, 16 plus 16 is 32 plus 16. No, we're going to break it up and make it way easier. That's what we're practicing today. So let's keep going. Okay, so let's try to solve this next problem. It says Meg bought 7 boxes of crackers. Each box has 62 crackers. How many crackers did Meg buy? Okay, this multiplication equation looks like 7 boxes with 62 crackers in each box. Who here knows 7 times 62 off the top of their head? No one? No, me neither. So, in order to solve this, we can break it down, partition the rectangle into easier to solve pieces. Do you think it's smarter to break up 62 into smaller pieces or to break up the 7 into smaller pieces? I think probably 62 because that number is enormous. So when you're partitioning a rectangle, you want to break the number 62 up into two numbers that are much easier to work with. Now, oftentimes you want to consider breaking it up so one of the numbers is a 10, a number that ends in a 0. So I can do this because I know 60 and 2 are broken up to be 62. 60 plus 2 is 62. So if I were to partition my rectangle, this side represents the 60, this side represents the 2, and there's 7 for both sides. Now my problem looks like this. 7 by 60 crackers, and 7 by how many? 2 crackers. Okay, 7 times 2, I have fact power for. It's a doubles fact. 7 times 2 is 14. If you remember back to a few lessons ago, solving multiplication problems with the 0 at the end are easy if we solve the base fact first. So instead of looking at 7 times 60, look at 7 times 6. What's 7 times 6? That still is kind of a hard fact, but we should start learning it. 7 times 6 is 42, but we have 6 tens, so it's 42 tens. 7 times 60 is 420. Now to figure out how many crackers Meg bought in all, we have to take our two partitioned pieces and add them together. 420 plus 14 equals, let's check it out. 0 plus 4 is 4. 2 plus 1 is 3. 4 plus 0 is 4. How many crackers did Meg buy? She bought 434 crackers. Okie dokie, friends. So your assignment today is to work on page 836 in your math journal. So I'm going to walk you through some of these problems. If you're feeling comfortable with decomposing factors to multiply, you can stop watching the video now. You don't have to continue. But if you feel like, you know what, I'd like a little bit more practice with it, then I will take this time to help you practice. So go ahead and flip to page 287. Number ones, or the directions, are to use the break apart strategy to solve the multiplication problems. That's what we just practiced. Think of easier multiplication problems that you can use to break apart the larger factor. Draw rectangles and write number sentences to show your thinking. Okay, number 1, 7 times 24. I don't have fact power for 7 times 24. I can break blank into blank. What it's asking us here is to pick the number that we would like to break apart. You can choose either one, but in my opinion, 24 is the difficult number there. So I'd like to break 24 up. What two numbers could we break 24 into to make them easier to work with? Now remember, it's often easier to use a 10, a number with a 0 at the end when you're breaking apart numbers. I'm going to break 24 into 20 and 4. Okay, you could do 10 and 14. You could do 12 and 12. You could even do more than two numbers. There's no one right way to do it. It's whatever's easiest for your brain. For me, in my brain, it's 20 and 4. So that's what I'm going to model. So let me go ahead and partition a rectangle. Wow, that That is a nice rectangle right there, if I do say so myself. Okay, so one side represents 7, and then this side is 24, but we split it up into 20 and 4. Okay, so I'm going to partition it, break it up. Now, this side, 7 times 20. And this side, 7 times 4. All right, let's do 7 times 4 because that one's a little bit easier. 7 times 4 is, go ahead and solve it, 28. And then 7 times 20 you may not know, but you do know 7 times 2. 7 times 2 is 14, but it's not just 2, it's 2 tens. So instead of 14, it's 14 tens, or 140. Then with our two numbers, we have our partitioned rectangle over here, our partitioned rectangle over here. We need to add them together, see what we get. 140 plus 28. 0 plus 8 is 8. 4 plus 2 is 6. 1 plus 0, 1. We get 168. So don't forget to plug your answer back in the answer spot. 7 times 24 equals 168. Not bad. Okay, for number 2, same strategy here. We have 4 times 36 equals, I'm not sure. So I can break blank into what? Again, I'm going to split up the bigger number here, 36. That just seems really tough to work with. So if I split 36 into two easier numbers, I'm thinking the 10, 30, and then the leftover ones, 6. 30 and 6. So if I draw my partitioned rectangle, oh look, I'm getting better at drawing rectangles. Not bad, Miss Kine. All right, we have 4 on one side, and then 36, which, remember, is being broken up into 30 and 6. My equations, we have 4 times 30, 4 times 6. I'm going to do 4 times 6 first because that one's, I have fact power 4. 4 times 6 is 24. And then 4 times 30, well, we know 4 times 3 is 12. It's not 3 ones, it's 3 tens, so 120. Then we take our two totals and add them together to figure out our answer. 120 plus 24 equals 144. And don't forget to plug your answer back into the top. 4 times 36, 144. Awesome. Okay, friends, last but not least, I'm going to help you break it apart, but I want you to solve it on your own. 8 times 57. I can break blank into blank. Now, my recommendation is breaking up 57. You don't have to. You can break up whatever you want to make it easier, but 57 to me is a pretty hard number to work with. So I could break 57 into 50 and 7. Now, see if you can partition the rectangle just like we did in the last problems and solve each multiplication fact. Then you add them together to get your total. Try number 3 on your own. Do the best you can. And then if you need some extra practice, if you want more work today, you can go onto Math Box page 288. But if this is enough, you got your half an hour math in, then I'm fine with you stopping after you finish number 3 on your own. Good luck. I know you can do it. Look back at the other problems if you want a reminder of how to do them. All right, friends, nice work today. I'll see you next time.